Hi friends, welcome back. We're talking today about rhombi. That is the plural form for a rhombus. If you have more than one rhombus, you have rhombi. So grab your notebook. You're going to want to take some notes on what these properties are. If you have not yet figured it out by now, there are a lot of properties for quadrilaterals, and you cannot remember them all unless you practice and write them down. So do me a huge favor and do yourself a huge favor. Grab your notebook. We are going to write some of these down. So without any further ado, here are our properties for a rhombi, or for a rhombus, which is that some pair, you know what, let's back up. Remember, quick refresh here. We have quadrilaterals are four-sided polygons. Some four-sided polygons are parallelograms. Some parallelograms are rectangles. Some parallelograms can be a rhombus. So when we look at this, some parallelograms are rhombi. If you have determined something is a parallelogram, check to see if it is a rhombus. And how can we do that? Let's see. Not only would all of those properties of a parallelogram apply, but then these additional properties would apply as well. So we have all the properties of a parallelogram, which you can go back and look in your notebook because, of course, you've been writing it down in your notebook. Secondly, all the sides are going to be congruent. So that's a little bit different than a parallelogram in that all our sides are congruent. Our diagonals are going to be perpendicular. That upside down T there is the shorthand for perpendicular. And remember, perpendicular means 90-degree angles. So these guys right in here are going to create 90-degree angles, all of those all the way around. The other thing is, and the sides are all congruent. So when we go to draw, I drew a very large rhombus here, but you can probably draw a smaller one in your notebook. Then the other thing is the diagonals bisect the opposite angles. So unlike a rectangle, we talked in a previous video about rectangles, even though the rectangles have 90-degree angles, they don't bisect them. They're not 45-degree angles. The diagonals don't bisect them. But in this case, they absolutely do. So we don't know that they're 90 degrees, but we do know that they are congruent to each other. So this guy is going to be congruent to this. This guy is going to be congruent to this one right in there. And those are the properties of your rhombus or rhombi. So we have, and just as a reminder, here's all your properties of a parallelogram. So all of those apply as well. Pause the video if you need to watch that. Okay, so let's talk about how that applies when it comes to practicing. So take a minute, draw this rhombus as best you can in your notebook, and we are going to talk about finding these measurements. So let's see, for the measure of angle 3, it is 62 degrees. The measure of angle 3 is 62 degrees. So what does that mean? Measure of angle 3 is 62 degrees. Let's write that in here. All right, so the measure is 62 degrees. Now we have to find the measure of angle 1 and the measure of angle 4 and the measure of angle 6. Okay, well, what we just learned in our rhombi is that our rhombi, the diagonals, words are hard, sorry, the diagonals form 90-degree angles. So if we come back over here, that straight away tells me that angle 6 here is a 90-degree angle, which means all these other ones are too, because vertical angles and linear pairs, all of those are 90 degrees as well. I cannot draw a 90-degree angle to save my life there. Okay, so if we know that this is 62 degrees and we know this is 90 degrees, notice that if I use my fancy highlighter here, these guys are just a triangle. I can never find a highlighter when I need it. This guy right here is just a triangle. And a triangle has 180 degrees. So if we take 180 degrees and we minus this 90, that leaves us with 90 degrees. So if we take 90 degrees and we minus this 62 here, we are left with 28 degrees. So we now know the measure of angle 1 is 28 degrees, 28 degrees. Okay, what about the measure of angle 4? All right, so taking a look at that then, we have these, let's see, the other part of this is that these bisect each other. So the measure of angle 4 is also going to be 62 degrees here. So if we look at that one's just, we can put 62 degrees right in here. Okay, and so what is the measure of angle 6? Well, we figured that one out pretty early on because it's right in the center of those diagonals. It is a 90-degree angle. Okay, so that is applying the rules of those angles for our rhombi now, or the properties I should say. Now, what about these other ones? We've got the measure of angle 3 is 2x. Okay, so the measure of angle 3 right here is 2x plus 30. This no longer applies, so I'm going to cross that out. And the measure of angle 4 is 3x minus 1. Well, if you look at this again, because they bisect each other, angle 3 and angle 4, just as we showed here, are also going to be congruent. So we can say 2x plus 30 equals 3x minus 1. Okay, so let's go ahead and minus 2x from both sides. And at the same time, I'm going to add 1 to both sides. So this gives us 31 equals x. Okay, and the instructions don't say what we're supposed to be doing here, but we're supposed to be finding x, which we have done. So excellent job. Get it? Excellent job. I'm hilarious. All right, so now let's talk about how this applies to our sides and all the rest of our rhombus. Okay, so we know AH is 24 and ST is 16. So we know AH right here is 24 and ST is 16. Okay, so we know this guy right here is 16. Now, the diagonals bisect each other, meaning that because this is 24, we also know this guy right here, that's going to be a 12. All right, so what is AS? Well, AS, we just answered that. That is going to be 12. What is SH? SH is also going to be 12. Now, what is going to be MT? MT here is going to be 16 and 16, which gives us 32. Now, here's the fun one. For this one, AT, you'll notice, again, this is a 90-degree angle. So we have a 90-degree triangle written up here. It might help if I rewrite it like this. Let's see if I can do my sideways. That's a 90-degree angle. Okay, so here's the triangle that we have. This is A, this is T, and we know this is 12, and we know this is 16. And then this guy right in here is S. So remember, with a 90-degree triangle, we can always use our Pythagorean theorem, which is a squared plus b squared equals c squared. And that should give us this AT right here. So if an A and B can be either of our legs, it doesn't matter which is which, but our hypotenuse is always opposite our 90-degree angle, and it is always our largest side. So we reserve that for C. So 12 squared plus 16 squared equals C squared. Okay, so when we do 12 squared plus 16 squared, we end up with 400. So 400 equals C squared. If we square root both sides of those, we end up with 20 equals C. So we now know AT is 20. For any of you keen observers who are familiar with with Pythagorean theorem and with your Pythagorean triples, which are the friendly Pythagorean or friendly right triangles where you get whole numbers, right? Let me write this down before I forget that part. Okay, so that's 20. You'll notice that if I divide all of these by 4, so if I divide this guy by 4 here, I get 5. If I divide this by 4, I get 3. And if I divide this by 4, I get 4. And so I have a 3, 4, 5 triple. That is a very common Pythagorean triple, 3, 4, 5, multiples of that, because it's just nice and pretty, and you get a nice even hypotenuse on all, or a nice even side on all your sides. Okay, so those are the properties of a rhombus. If you have any questions, let your teacher know. Otherwise, great work, and I will see you next time.